Alright, so in this video we're talking about solving systems algebraically. Now, this method, we're going to talk about two methods here in this video, substitution and elimination. You can use either one of these methods, but you can also use the graphic method that we talked about in the previous video. Whatever suits you, whatever floats your boat. Alright, so substitution, you can read this on your own, but essentially what we're going to do is solve one of the equations in our system for a particular variable. Once we have that particular variable by itself, we're going to substitute it into the other equation in our system, and then solve. So let's do an example real quick. So here I want to pick one of the equations and then decide which variable do I want to solve for, which variable do I want to get by itself. So that's typically up to you. I'm going to solve the bottom equation for x. So I'm going to solve the bottom equation for x because that looks a little bit easier. You always want to make life as easy as possible for yourself. So I have x plus 2y is equal to 2. And give x by itself, so x is equal to 2 minus 2y. Okay, so what that means now in the top equation, everywhere I see an x, instead of writing x, I can write 2 minus 2y. So let's do that. So I have my top equation. 3x plus 4y is equal to negative 4. And everywhere I see an x in this equation, instead of writing x, I'm going to put in 2 minus 2y. So I have 3, and then 2 minus 2y plus 4y equals negative 4. Now, you might notice that I put parentheses around here. Now, why is that? Because it's 3 times whatever the value of x was. Well, x had a value of 2 minus 2y. There was multiple pieces there. So every piece has to be multiplied by 3. Otherwise, you're going to get it wrong. So watch out for that. So now it's just simply distributive property. So we have 6 minus 6y plus 4y is equal to negative 4. Now we combine like terms before we start moving things around. So we have 6 minus 2y is equal to negative 4. And we want to get our variables on one side and our constants on the other. So to do that, I want to just simply subtract 6 on both sides. So I have negative 2y is equal to negative 10. And divide by negative 2 on both sides. So I have y is equal to positive 5. Alright, so now that I have the value of y, I know exactly what y is. I'm going to go back to this equation over here that I just found. And everywhere I see a y now, I could substitute in a 5. Okay, so let's do that. So x equals 2 minus 2 times 5. And I'm just going to simplify that. So x is equal to 2 minus 10. So x is equal to negative 8. Alright, so now I found the value of x and y, so I'm ready to write my final answer. So you should always write your final answer since we're talking about ordered pairs. We're looking for the point on the graph where there's an intersection point. So our solutions are always ordered pairs. So we should write our final answer as the ordered pair. So the final answer is going to be negative 8, comma 5. This is our x, this is our y. That's the final answer. There's only one intersection point, there's only one solution. Okay. Now elimination, again, you can read this if you want to, but essentially what we're doing here is a little bit different from substitution. Some people like substitution more than they do elimination. I personally prefer elimination, just personal preference. You choose what's better for you. But what we're going to be doing is adding, subtracting, multiplying the equations together to literally eliminate a variable of your choice. So let's go and do it. Alright, so here in this equation, what I want to do is first pick what variable do I want to eliminate. Okay, I'm going to try adding to eliminate the variables. If that doesn't work, I'm going to try subtracting to eliminate the variables. And if that doesn't work, well then I know I need to multiply one of my equations to get an additive inverse of the variable I'm interested in. So I want to eliminate the x's. That's totally my choice. You could eliminate the y's. Eventually, if you do your math right, we should end up with the same answer. I want to eliminate the x's though. So if I try to add these together, I'm just going to go through my 3 operations that I'm trying. I have 2x plus 4x, which is 6x. Well, the x's aren't eliminated. That's a problem. So I know addition is not going to work right on its own. So now I'm going to try subtraction. So I have 2x minus 4x. That's negative 2x. The x's still aren't eliminated, so still have a problem. So instead, what I need to do, since I'm trying to eliminate the x's, I need these x's to be additive inverses of each other. Well, I already have positive 4x, so what that means is I want the top equation to have a negative 4x. But the easiest way to accomplish that is to multiply the entire top equation by -2. So that's what I'm going to do. So I'm going to multiply the entire top equation by -2. All right, so what you do on one side, you have to do on the other, so be aware of that. So I have -4x, excuse me, -4x plus 8y, because we had negative, so be careful about that, equals -26. And then my bottom equation, I'm just going to bring down. So I have 4x minus 5y is equal to 8. Well, now what I want to do is go through my operations again and try to eliminate my x's, because that's what I chose. Well, I'm going to try addition first. But clearly, -4x plus 4x, those do eliminate. They do cancel out. I have 0 x's remaining. Now I go through and add the rest. 8y plus -5y is 3y. -26 plus 8 is -18. Now we can get y by itself. Super easy at this point. So y is equal to -6. Well, we still need to find the value of x. So what I have to do now is pick either the first equation or the second equation, and everywhere I see a y, I'm going to plug in. Now, typically, as always, you want to make smart choices, make life easier on yourself, but there really is no smart choice here for what we have. So what I'm going to do is just pick the top equation. Again, it works the same if you pick the bottom equation. Just plug in, do your math correctly. Be careful, don't make mistakes. So looking at my top equation, so everywhere I see a y in my top equation, I'm going to plug in a -6. So just rewriting my top equation is 2x minus 4y equals 13. That's the equation I'm going to be using. So I've got a little bit of room now. It's going to do it. Everywhere I see y, plug in a -6. So 2x minus 4 times -6. And that's equal to 13. Okay, let's go through and simplify. So I have 2x, negative makes a positive, so plus 24 equal to 13. And now simply solve the equation, get x by itself. So subtract 24 on both sides, so 2x is equal to -11. So x is equal to -11 halves. All right, so now we can write our final answer as an ordered pair. So we need to do that. So our answer is -11 halves, comma, -6 x 1. Now, if you're ever not sure about this, because we did get a fraction for our x, and a lot of people, for whatever reason, when they see a fraction in their answer, they get scared. What you can do is go back to your original equation, and like we did in the previous video, plug in this ordered pair. Everywhere you see an x, plug in 11 halves. Everywhere you see a -6, plug in -6. And what should happen is you should get true statements. Okay, you should get true statements on both sides. Okay, we want to solve this equation. So we're going to use the method of our choice. It just says solve. It doesn't tell us what we're going to do. So I look at it, I see, there's really no tricks here that can really help. So what I'm going to do is just do elimination, because that's what I prefer. Okay, so doing elimination, this time, just for fun, I'm going to eliminate the y's. So obviously adding is not going to work because I don't have additive inverses. Subtraction is not going to work because I don't have additive inverses. So what I have to do then is I'm going to have to multiply. And this time I'm going to have to multiply both equations. So I want to find a common factor that's going to be nice. So 24 is probably going to be my smallest one. You can go higher than you want. So to make a -24 here, a -24y, I'm going to have to multiply by the top by +3 on both sides. And then to get a +24 on the 24y on the bottom equation, I'm going to have to multiply by +3 on the bottom equation on both sides. So let's just rewrite it. So top equation, I end up with 21x minus, oops, and this should be a +2 up here, excuse me, because I want to make a 24. So I'm going to multiply both sides by 2, excuse me. So that's 14x minus 24y is equal to -44. Okay, for the bottom equation, multiply everything by +3. So I have -15x plus 24y, and then 3 times 14, let's see, so that's 42. Okay, so now we're going to eliminate by adding both equations together. So we're adding both equations together. So 14x minus 15x, that's negative x. Negative 24y plus 24y cancels out. So we're just equal with negative 44 plus positive 42, so negative 2. So negative x is equal to negative 2, which means x, positive x, is equal to positive 2. Okay. Now, just like before, we can go ahead and plug in, choose one of the equations, and everywhere we see an x, we can plug in and get y. So I'm going to plug into the bottom equation this time. So let's just rewrite that. So my bottom equation originally was negative 5x plus 8y equals 14. Let's get some room. So now everywhere I see an x, I'm going to plug in a positive 2. So I have negative 5 times positive 2 plus 8y is equal to 14. Okay, so I have negative 10 plus 8y equals 14. And now just solve this equation by adding 10 on both sides. So we have 8y is equal to 24. So y is equal to 30. So now we're ready to write our final answer. Remember, we're talking about ordered pairs. So we have our ordered pair is 2, 3. That's it. All right, let's solve this one. So again, we want to use whatever method we choose. Looking at it, it looks like it might be a little bit easier to do substitution on this problem. I'm going to look at the first equation and get x by itself. So to do that, I have x minus 2y equals 3. And getting x by itself, by just adding 2y to both sides, I have x is equal to 2y plus 3. Now, what that means is, in this bottom equation, everywhere I see an x, I can plug in 2y plus 3. So that's what I'm going to do. So 2x minus 4y is equal to 7. And everywhere I see an x, now I'm going to plug in the value 2y plus 3. Oops. So 2 times 2y plus 3 minus 4y, and that's equal to positive 7. Okay, so now we have distributive property again. We had 2 pieces for the value of x, so we need distributive property. So we have 4y plus 6 minus 4y is equal to 7. Combine like terms. We have 4y minus 4y. Well, that means we have 0y, so y's actually cancel out here, so we just have 6 is equal to 7. Wait a second. 6 equal to 7, that doesn't make any sense at all. We know for a fact that 6 is not equal to 7. So we know that actually 6 is not equal to 7. So what that means is, what that tells us is there's actually no way possible for there to be a solution. So there's no solution. What that means is there's no intersection points. What that means is these lines are parallel. If we got these equations, we got y by itself, what we would find is we would have the exact same, we would have the same slope, but different y-intercepts. The exact same slope, but different y-intercepts. There's no solution. These lines are parallel. Okay? And the last one here. Okay, so what we're going to do is do the same thing. We can either solve by substitution or elimination. So here, I think elimination might be more easy to do. So I'm going to eliminate, let's see, I'm going to eliminate, well, there's really no good choice here, so let's eliminate the y's. Okay, so to eliminate the y's, I want my y's to be added to the inverse of each other. The common factor that I can think of that would be easy to get by multiplication would be positive 50. Okay, so to get 50, or negative 50 up here in the first equation, I'm going to multiply by negative, or positive 5. Multiplying by positive 5. The bottom equation, I want a positive 50, so I'm going to multiply by a positive 2. So taking care of the top equation first, I have 30x minus 50y, and that's equal to 60. The bottom equation becomes negative 30x plus 50y is equal to negative 60. All right, so now we know we want to use addition to try to eliminate our y's. So 30x plus negative 30x, well, that cancels out. And then negative 50y plus positive 50y, that cancels out. And then, so on the left, we're just left with 0 equals, and then 60 plus negative 60 cancels out, so we're just left with 0 equals 0. Well, that's strange. But we know that 0 is always equal to 0. So 0 equal to 0 is always true. So what that means is there's infinite solutions. Okay, so we get something equal to itself, something that's always true. No matter what we do, we're going to get a true answer, no matter what. So that means that there's an infinite number of solutions. There's an infinite number of intersection points, which means if we got y by itself, from these two equations, we would find that, hey, we end up with the exact same line. Okay, those slopes match up and the y-intercepts match up. So watch out for that, because that's the end of this video.